So the first thing we're going to do is go through the answers for last week's homework on metamorphic rocks. So you will have done question 27 to 52. Okay, so let's get started. Describe the physical properties of metamorphic rock. So you will have read up here about metamorphic rock, and I explained it last week. So we can see up here that they are resistant to weathering, and they are hard wearing. Okay, hard wearing. What happens to the temperature of the Earth as you get further underground? It increases. And what does density mean? So you should remember from a while ago when we did about density that it's the amount of mass in a certain volume. So if there's more mass in the same volume, then it's got a higher density. Okay, name the sedimentary rock found in the white cliffs of Dover. That is limestone. What type of rock is formed inside a volcano from magma? That's igneous rock, but because it's formed inside, I can say even further than that, that it's intrusive. Igneous. What is the thinnest section of the Earth? That's the outside, that's the crust. And describe how metamorphic rocks are made from sedimentary rocks. Well, they are subject to, so they experience high heat and pressure. Changes them from sedimentary to metamorphic. Okay, so high heat and pressure changes them from sedimentary to metamorphic. Question 34. Helen weighed 3 pieces of rock and soaked them in water. So we've got granite, marble, sandstone. Okay, so granite, that's igneous. Marble, that's a metamorphic. And sandstone is sedimentary. Rocks that have lots of small spaces are described as porous. Okay, so porous like a sponge. All right. What evidence is there in the table that sandstone is porous but granite and marble are not porous? So we can see that the mass before and after soaking in water does not change. No change. Marble, no change. So what we can say about these two is that they haven't absorbed any water. All right. If you think about the sponge that you might use when you do the washing up, if you squeeze it out, all right, it'll be quite light. But then if you submerge it in water and take it out, it should be heavier, and that's because of all the water it's holding. And we can see that's not happening here because the mass has not increased. However, for our sedimentary rock, we have got an increase in mass. Okay, so what evidence is there? Mass has increased. Mass has increased. Okay. Helen put the soaked sandstone into a freezer for 24 hours. Water in the spaces in the sandstone froze and expanded. What would happen to the sandstone as the water froze and expanded? Well, it would crack and break. In the winter, this process happens in rock in the countryside. This is called freeze thaw weathering. Helen placed fresh pieces of granite, marble and sandstone in beakers of dilute sulfuric acid. Only the marble reacted with the acid. Use Helen's results to explain why granite is more suitable than marble for a statue in a city centre. Okay, will not be affected by acid rain. Okay. because that's essentially what's happening here. You're simulating the effect of acid rain by adding dilute sulfuric acid. So if there's a small amount of acid in the rain, then it would have an effect on the marble statue. Okay, very good. 38. Draw a line from the name of each rock to the group of the rocks it belongs to. So granite is a type of igneous rock. Marble is a type of metamorphic rock, and sandstone is a type of sedimentary rock. Draw a line from each group of rocks to the way the group of rocks was formed. So sedimentary is formed when particles are deposited in layers. Igneous is formed when magma cools. And metamorphic is the high effect of temperature and pressure. So it should look like that. The list below gives some processes which occur in the rock cycle. Give the number of one metamorphic process. Okay, so metamorphic, we're making things like marble, we're thinking about high heat and pressure. Here we go. New crystals form in layers as rocks are affected by high temperature and increased pressure. So number 5, that would be a metamorphic process. Give the number of one igneous process, so that's when molten rock cools down. So I could have here, number 2, large crystals form as molten magma cools below the Earth's surface. Or I could have a glassy rock forms as molten magma erupts into seawater. All right, so I could have 2 or 3. And in fact, you might want to go, if you go on the internet, you can see videos of that. Maybe I'll put one in the task where you can see the magma falling into water and cooling immediately to form rock. It's quite interesting. Give the numbers of the 2 steps which could lead to the formation of sandstone. All right, so sandstone is a sedimentary rock. So that is going to be, first of all, grains of sediment collect on the seabed, so number 1. And then those grains of sediment are cemented together, so number 4. Limestone and sandstone are 2 different rocks. Limestone is mainly calcium carbonate. It reacts with dilute hydrochloric acid to produce bubbles of gas. Okay, so you should know this equation, but you should also be able to work it out here. So bubbles of gas, that's going to be our carbon dioxide. And there will be a salt as well, which will be our calcium. And because it's hydrochloric acid, it's going to be a chloride salt. So it'll be calcium chloride. Okay, 45. Sandstone is mainly silicon dioxide. Glass for test tubes is also made from silicon dioxide. Suggest what, if anything, will happen when dilute hydrochloric acid is added to a piece of sandstone? Well, you know that if you put dilute hydrochloric acid into a test tube, nothing happens. Okay, that would be a really bad test tube if when you put an acid in it, it dissolves. Okay, so if I put the acid in a test tube, nothing happens. And the test tube is made from silicon dioxide. Sandstone is made from silicon dioxide. So if I add dilute hydrochloric acid to sandstone, nothing will happen. Because they're both made from the same material. So test tubes and sandstone are both silicon dioxide. Okay, question 46. When sedimentary rock is buried, it may change into metamorphic rock. Describe 2 causes of this change. Heat and pressure, obviously. You should know that. Name a rock formed by the metamorphism of limestone. Marble is what you get. So obviously, depending on what kind of sedimentary rock you have, you're going to get a different kind of metamorphic rock. So if the sedimentary rock is limestone, the metamorphic rock is marble. Metamorphic rock can be changed to form igneous rock. Give 2 main processes which are involved in this change. So I want to go from metamorphic to igneous. Right, so now you've got to start thinking, well, how can I get from this type of rock to this type of rock? Well, I know that the last stage in the formation of igneous rock is molten rock cools to form igneous rock. I know that's the last process in the formation of igneous rock, molten rock forming, cooling. But I've got metamorphic rock, so how can I get from metamorphic rock to molten rock? Well, it would just be metamorphic rock would need to, metamorphic rock melts to form magma. Okay, and you can imagine that happening if you've got deep down inside the Earth's surface. Okay, this is a volcano, all right, and you might have here, this is a magma chamber, so this could be magma, all right, and you've got layers of sedimentary rock here. Okay, and as these layers of sedimentary rock get pushed further down, okay, they'll get closer and they'll undergo high heat and pressure here to form metamorphic rock. And then as they get even closer to the magma, eventually the temperature will become so high they'll melt and they'll go into the magma. Okay. Igneous rock may be changed into sedimentary rock. The list shows 4 processes involved in this change. Put them in order. Okay, this is straightforward. So it's going to be weathering, transport, deposition, and burial. And then we have 3 types of rock: granite, igneous, marble, metamorphic, shale, sedimentary. Okay, and we're asked in the table below, draw lines to connect the names of each rock. So, layers of mud and tiny dead animals compressed and turned into rock. That sounds like a sedimentary rock to me, and I know that shale is a sedimentary rock. Magma cooling slowly underground in the Earth's crust. That's going to be igneous rock, and our igneous rock is granite. And limestone changed by heat and pressure, metamorphic, and I know marble is a metamorphic rock. And the features of the rock, well, large interlocking crystals is going to be, well, I know that igneous rocks have crystals, and because this is cooled slowly, those crystals are going to be quite large. Remember, if it cools slowly, the crystals are large. If it cools quickly, the crystals are small. Crumbly, layered, and containing fossils, sedimentary. Remember, sedimentary has fossils, metamorphic does not, because they've been subject to the high heat and pressure. Hard, shiny, white with veins of colour, and it fizzes with acid. Sounds like marble to me. Okay, and finally, explain how chemical weathering causes caves to form in limestone. Okay, so chemical weathering. All right, so we're talking about things like acid in rain, water. All right, how will it form a cave? All right, well, it will, acid in the rainwater causes the limestone to corrode, forming a cave. And 52. Limestone is a porous rock. Water can enter the spaces in limestone. Describe how this causes physical weathering of the limestone. Okay, so we could have here any description again of the freeze-thaw weathering process. All right, good job, well done.